Okay, this is a circular motion question, but on a bank track. But anyway, let's read it. So there's designing a curve on a high-speed railway track to prevent excessive wear, and for the comfort of passengers, it's important for the track to be correctly banked, so there are no sideways forces between the rail and the wheel of the train. This is shown in figure 4A and 4B. Radius of the curve is 2,000 meters. The speed of the train is this. On figure 4B, here's figure 4B here, draw two arrows that show the external forces, basically the actual forces acting on the train, and a third arrow marked F net to show the net force on the train. Well, the obvious one is the force of gravity, and make sure you use a ruler with these. The other one is the normal force. The normal force always goes perpendicular to the plane. So the normal force comes up here. I struggle to use a ruler on this computer here. That should be a straight line, and it should be at 90 degrees to this bank here. If you drew an arrow up, or even like that, it's hard to tell if it's not that perpendicular. You get the mark wrong. That's my normal force. Then the net force is the third arrow we have to draw. It goes towards the centre. It doesn't go down the ramp. If it went down the ramp, the thing would be accelerating, rolling down the ramp like a ball or a trolley rolling down the ramp, like in question 1. You've got to do this one as parallel to the bottom line here. So again, you'd be using a ruler. It's as straight as I can get it. And this, they asked you to label this one, F net. Okay? If it's not clear, if you're halfway between straight and down the ramp, again they'll mark it wrong. You have to be very clear about what the answer is. Right, calculate the correct angle of the bank for the track to the horizontal for there to be no sideways force on the wheels on the track. Show steps you're working. Right, the formula that I have on the cheat sheet is when there's no other forces apart from these two. The formula is tan theta equals centripetal force over mg. If you put the formula for centripetal force in, actually no, stop here. A lot of people got as far as this, well, they started this question and started looking around for the mass, and there was no mass and they couldn't find it, and so they thought that I'd done something wrong or that I'd given up. But if you expand this out and put the centripetal force equals mv squared over r, what you'll see is mv squared over r over, here's the big over, mg. The m's cancel out, and you're left with v squared, if you simplify that, over rg. So tan theta equals that. So in this case, tan theta equals 50 squared, was the speed I think, yeah 50, over 2000 times 10, which is tan theta, if you put that in your calculator, those ones equals 0.125, then you find theta equals tan negative 1, 0.125, which gives 7.1 degrees. Here's another tip as well. Make sure, before you even go into the exam, your calculator is in degree mode, not radian or grad mode. Okay? Make sure it's in degree mode. So don't ask any radians in the physics. All you're asked for is degrees.